Sure.
Cool.
Just needed to understand.
Yeah, no, appreciate the comment. All right, so let's get started then. We do have a bit more of like a presentation-y type content today, and I'll get into the details in a second. But I mean, yeah, like I was saying, I think this program, as we go from week to week, it's really supposed to have an emphasis on peer-to-peer engagement and knowledge sharing within the community. So definitely trying to foster that. Although this session and maybe the next week or so, first few weeks, will be a little bit more content and lecture-y. But yeah, cool. So let's get started. The cadCAD study group is a partnership between the cadCAD community and the Token Engineering Academy. As soon as these slides load. There we go. Okay. And just a heads up that we are recording the session. We'll do that each week, post it on the YouTube channel, and yeah, for everyone who isn't able to attend. So quick to start out, I'll just give a quick intro. Hello from the Token Engineering Academy. I think everyone here pretty much knows the Token Engineering Academy. You've made it to the Discord. TE Academy is focused on creating structured education opportunities for token engineers. And that comes in a lot of different forms, different types of programs, partnering with different crypto projects out there. But overall goal and mission is developing the new token engineering discipline, educating aspiring token engineers, growing the number of token engineers in crypto, and creating new Web3 value flows in the education space. And obviously the most recent partnership has been with cadCAD in launching this study group. So for today, you're stuck with me for a little bit, a few slides. We're just going to go into the study group, some of the study group details. So you actually have an idea of what you're here for, the goals, the structure, the logistics, and then we'll have some time for questions in the end too. And then we will get into some content. So we're going to get a bit of a crash course on cadCAD from Tyler, who's also in the call. So yeah, let's get started here. Study group goals. So why are we actually organizing this cadCAD study group? So we want to encourage peer learning and knowledge sharing in the growing cadCAD community. I think just in the last few months and year, the token engineering space has grown significantly, and we've noticed that in the cadCAD community as well, with just the number of users and the adoption of the tool. And so we really want, being an open source project, we really want it there to be this culture of peer learning and knowledge sharing and supporting others that are working with the tool. We also want to support motivated community members in contributing to the cadCAD Commons. So the Commons is going to be a focus of this study group as well, being like the public repo, public documentation, the public blog, the Ghost blog. And so we want to create an opportunity or sort of a structure for community members who want to contribute to cadCAD to be able to do so. And finally, giving the community a first look at some of the new concepts being introduced in cadCAD 1.0 and a space to start applying them. So cadCAD 1.0 is an upgrade to, or a rewrite of the existing cadCAD versions out there. And Tyler will be able to give a lot more detail on this, but there will be some new concepts introduced, and this study group is a good space to get a look at some of those and be able to start applying them with support and with other people who are learning along the way. So,
Peter,
yeah,
where are the slides?
you should be able to.
You might have to click on Heater's
user
in order to see.
I did.
I'm sharing my screen.
If that doesn't work, sometimes Discord has problems. I would recommend dropping from the call and then rejoin and see if you can see it then.
Okay, that was not part of the instruction. I'll try that.
I'll reshare too, just in case. Okay. Is that working for other folks?
Yeah, I'm seeing that.
I can see it.
Yeah, I can see it.
I can see it. Good. Are you going to be sharing a link to the slides as well?
Yes. Yeah, all of this will be shared afterwards. Okay. I think we're back up. Holler if it's not working for you. Cool. So those are the study group goals, why we're here. As for the study group structure, so we're going to meet weekly on Tuesdays from 5 to 7 p.m. So we have a 2-hour time slot. Just a fair warning, I think it's daylight savings in various parts of the world, so keep an eye on the time over the next few weeks. Weeks 1 through 3 of the study group will be, as I said, a little bit more content than the weeks after. So we're going to start with a bit of a crash course on cadCAD and some of the new concepts from 1.0. As I mentioned, Tyler's going to cover a few of those today after these slides. And then from week 3 onwards is really when the peer learning starts. So that's going to be kind of when we have more active engagement, and we've got a little bit of a foundation from the first few weeks on what cadCAD is. So weeks 3 onward is going to be actually focused on participants defining our own learning goals and working towards this contribution to the cadCAD Commons. So that again would be like the repo or the Wikipedia for documentation or the Ghost blog. And the sessions will include kind of a mix of progress updates from people who are working on their learning goals, group live hacking, troubleshooting to get past blockers, and presentations of completed work as we get there. And then also there will be one cadCAD mentor in each of the sessions to offer some expertise and support. So overall, basically from week 3, there's a lot more flexibility in terms of like what happens in the sessions. We're going to be, I'll get into it in a bit, but we're going to be having people sign up to for time to cover some of the issues that they're having and be able to reserve space to troubleshoot as a group or just share progress or present that work. So with the support of a mentor too. And here's some babies crying. Hope the presentation isn't that bad. Cool. So then study group structure. So what are these learning goals that I mentioned that we're going to start with in week 3? The learning goals are going to be centered around the cadCAD framework or cadCAD 1.0. We would like to see contributions to the cadCAD Commons. So this is the public repo, documentation, Wikipedia, the Ghost blog. And as I mentioned, these are going to be self-selected. So we're kind of starting with what we know and pushing our boundaries to learn as we produce these or as we work towards these learning goals. So we did get a few questions in the Discord about the prerequisites question or that topic. And ultimately, I think that the answer is that there's basically no prerequisites. We're going to give a bit of a foundation on what cadCAD is and what 1.0, some of the new concepts from 1.0. But beyond that, you have your background and your experience, your expertise, and you should start with that and then think about how you want to use cadCAD. Like what do you want to use cadCAD for, and what might you set as your learning goal in order to get there. And if you have to learn, I don't know, if you have to start doing learning some math or systems engineering concepts or game theory or whatever it might be, then you can take this as an opportunity to dive in and learn that yourself. And obviously the peers and mentors will be there to help too. A couple examples of the learning goals. Obviously these are not exhaustive. I think we'll see a lot of creative ideas, but cadCAD 1.0 engine documentation for the wiki, a generalized basic AMM model for the public repo. So if you're looking at modeling DeFi protocols and you just want to get an idea of how to use cadCAD, an AMM is probably a great place to start. And just working on this, like a generalized model would be, I think, an incredible learning opportunity. And also like a suggested approach for cadCAD 1.0 agent-based model for the Ghost blog. So this is maybe a little bit more in depth, but if you're curious, if you're more experienced in modeling and you have used agent-based models before or you're familiar with them, maybe you want to figure out how to use cadCAD 1.0 for an agent-based model. Well, you could use this study group as an opportunity to create that approach, and with the support of peers and the mentors with more cadCAD experience, be able to get there. So yeah, so this is probably going to take a few sessions to sort out, even after the foundation knowledge from the first few weeks. You might still not know exactly what your learning goal is, but again, that's kind of what we're here for as a group, and we can give feedback on different ideas for learning goals, whether they're feasible, how they would work out, etc. So this will definitely take a bit of time to work out. Unless you have been using cadCAD for, or already started diving in the last few weeks, you might have an idea of what you want to learn first. So to fit with or as with other Token Engineering Academy programs, we do have a POAP opportunity. So for a bit of extra incentive to complete the program, we will be offering a POAP for successful completion criteria, and this includes basically completing one of the learning journey or the learning goals. So ending, from step one of like defining what you want to learn, and then kind of using each week to build or work towards your deliverable, and then finishing that and presenting it, along with giving feedback to 3 other peers who've completed as well, would earn you a POAP from the TE Academy. And there's a beautiful collection on the bottom if you're curious what they look like. And then finally, to get the most out of this study group. So we've obviously, as I've kind of mentioned, there's a lot of flexibility around what your learning goal is, how much time you're going to commit outside of the program, what your prerequisites are, or what skills you're coming into this program. So there's a lot of flexibility, but I think there's also a big opportunity to be productive. So to get the most out of this study group, I think being proactive in setting learning goals, asking for support, sharing progress, being supportive with
You're
others.
like chopping up.
Oh, really? Is it?
Hey, Peter,
Still
can you
tough?
just go back the last minute?
Yes.
Cool.
Can you still hear me? Here, let me try and.
You're good now.
I'm good now?
Yeah.
Okay.
Yeah.
Cool. I will give this a try. Was the POAP one of the slides that got missed?
It was the next slide. It was just like the previous 30 seconds. You were like rugging.
Okay.
It was like choppy.
Cool. So yeah, we'll start here. So how to get the most out of this study group. So as I've mentioned, there's a lot of flexibility within this program, whether it's, you get to define your own learning goal. There's not necessarily prerequisites. The time duration depends on basically how long it takes you to complete your learning goal. So there's a lot of flexibility, but there are also a few ways to get a lot out of it. So there's a few suggestions, basically being proactive in setting learning goals, asking for support and sharing progress, being supportive to others with resources and feedback in the individual sessions, and as I mentioned earlier, kind of starting with what you know, and pushing your boundaries. So learning. And then onto some of the logistics. So as I've said, this is an event, or this study session, study group will be held in Discord. So we are trying this out. We have, there's a Discord channel in the Token Engineering Discord called cadCAD Study Group. There's a voice channel, which you're all obviously in right now. So those are the 2 main points of communication for the program. We will also be sending out calendar, or there will be a calendar with the events on it. I'll share all these links also in the chat, after this session. But yeah, so there will be a calendar, will be located in Discord. And then finally, the one piece of like infrastructure for the program, we call this the one-stop shop. And this is a program or a document that we've had, that all Token Engineering Academy programs have. And it's just kind of the central point of information for yeah, everything related to the program. So we'll get more into that as we start to use it over the next few sessions and weeks. But we'll share the link in the Discord channel. So now, I guess hoping for some questions or comments. I think it'll probably be, it may be like tough to think about what, without having a learning goal necessarily defined yet for yourself. It may be a little bit tough to visualize, I guess, what the next few weeks will look like. But I really think that that'll kind of come together over the course of the program as we're introduced to some of the cadCAD concepts. So yeah, I'll just open it up for questions.
So is the focus going to be on cadCAD 1.0 as opposed to previous versions? Because I know things are changing quite a bit in 1.0.
Yeah, so we'll start with, so that'll be part of the content that we get for the first few weeks is some of the new concepts within cadCAD 1.0, and then we can start applying those to learning goals, whether we're like creating documentation about it or et cetera. But you could also, I mean, cadCAD is kind of a generalized framework, and so you could take that as your starting point and work from there. So it doesn't necessarily have to be code-based, especially if you don't have any experience with programming or coding, then maybe you would prefer to work on an article to help you understand cadCAD's use cases. So.
I would definitely say it's 1.0 leaning. It's going to be sort of our focus since we're putting all of our, energy into 1.0. We also don't want to, for people that are brand new to modeling with cadCAD, I think it's probably a worthy investment of time to just sort of focus on 1.0. But we realize you're catching us at a weird time because it's not finalized yet. But we do have stuff that's available, and so I would encourage anyone who's participating in the study group to try and stick with 1.0. But there's going to be some things that we just cannot do with 1.0 from the jump, and so you might need to take some of these concepts and ideas and translate them into the legacy CAD. But that's several weeks out before we actually get into modeling anything super crazy, I would imagine. For most people here, that's not something you can jump into right from day one. So by that point, a lot more of the 1.0 spec will be set in stone, and there'll be even more in the actual package that you guys can start, using. So
will you supply the link to the most recent updated beta version or alpha version or whatever it's called of that?
Yeah, absolutely. We can drop a link in the chat. Yep.
It's in the public repo, and just I want to underscore this point. 1.0 and legacy cadCAD are they're API changes, but what we're doing in 1.0 is really making sort of the ontology of how to build your model very explicit. We realized that was sort of one of the ways we could improve the user experience, particularly for people starting their journey on model building. So the things that you're going to take away, at least in the early days of this course and looking at 1.0, are skills that are easily transferable to building on the current production version of cadCAD. So there's not going to be any like major losses or having to relearn anything specifically from moving from one to the other. It'll be like any changes are really more on sort of like the API and how to express the models, but what we're focusing on now is really the fundamentals of how to think about your models and how to express them.
Hey, I have a question.
Yeah, go for it.
And during our study group, will we be going through stock and flow chart, and in terms of the right mathematical specifications to define them? Because I've been essentially, I read one of the books, Systems Thinking, and as I'm learning as I'm doing. So I would like to know if I could have any potential feedbacks in terms of how I am defining my stock and flow. the eventual cadCAD modeling process.
Mm-hmm. Yeah, I think Tyler could probably answer whether we'll cover it specifically in the first few weeks, but that's definitely a topic that you can get feedback on. I think that's exactly what we would want to have a chance to review as a group. If that's what you're working on and using cadCAD for, then you can bring it to the study group and get feedback from peers and the mentor also.
Great. And in terms of defining the math behind it, is that something that also possible?
Yeah, definitely. We can would be able to go over that and basically like learn in step in the programs, in the sessions, I should say. So yeah, those are definitely topics that we can bring up and discuss.
Great, amazing.
Cool. Any other questions? Awesome. Hoping that was somewhat clear. Obviously, we'll be around for questions and whatnot in the Discord channel. And yeah, I'm also personally going to be participating in the group, so I'm not just like the one who's here dropping in to facilitate the call or open it or whatever. I'm also planning to participate, so I'm looking forward to this. I'm going to be learning alongside with everyone, and excited to use this as an excuse to get some experience with cadCAD, learn about the new concepts from cadCAD 1.0, and yeah, put a little bit of structure, but not too much, around my learning journey personally. So I hope it's an appealing program, and I'm looking forward to working with you all and seeing what you all work on too. And then I guess I'll pass it to Tyler to go into the content for today. Oh, actually, I heard one person. Yeah, Ratio 13.
Yeah, sorry about that. Are y'all still doing the cadCAD community call weekly?
Yes.
Or is that okay?
It's monthly actually, but it's on
monthly.
the cadCAD calendar. It's what is it? First Wednesday of each month. So.
All right, great. Thank you.
Cool. Then yeah, I'll pass it to Tyler.
Cool. Awesome. Thank you. So I didn't end up doing an intro earlier while everyone else was, so I'll just do that real quick. My name is Tyler. I am working on the cadCAD reference implementation, which is often called 1.0. And the reason for that is because of some versioning problems that we've had with Legacy. We've just internally been calling it 1.0. But when we say that, what we're really talking about is this reference implementation, which is a rewrite from the ground up. So for those of you who have already used cadCAD in the past, this is a complete reimagining of what cadCAD is. The principles and sort of the concepts are all there, but the API for interacting with those concepts or expressing those concepts is going to be different. And we hope that the end result is that you're left with a framework that is easier to understand and intuit about, and also has a lot more code reuse. That's sort of like the one objective that I think a lot of people are looking for is if you're going to spend the time and energy writing a model, it would be nice to be able to reuse portions of that rather than having to reinvent the wheel with every single model you do. So those are some of our objectives with this rewrite, as well as getting some minor things like some persistent bugs that have been around and have been very hard for us to address because of the architecture of the old legacy. And then also just implementing semantic versioning, which is something that we didn't have in place. And if anyone's ever worked with non-semantic or unsemantic versioning, you know that creates a ton of problems. cadCAD 1.0, I'm one of a handful of people working on that. I also work with Block.Science and with Block.Science Labs. Fraser and Katoya, both on this call, are over there at Block.Science Labs as well, where we take cadCAD and put it into an online cloud-based IDE modeling environment. So definitely something you guys should check out if you get a chance. Okay, I'm going to go ahead and share my screen. Haxel, if you can just do me a favor, my friend, and kill yours. I think part of the reason why we have sharing and audio problems is because of the architecture of Discord. If more than one person tries to be the hero, there just isn't enough resources. I think we could probably, going forward too, just as an FYI, so I don't forget it. Heater, we could boost the server next time. I think right before a call, and just make sure. I think that bumps your resources so that people can run their cameras if they want. Multiple people can share their desktop. I'm gonna share mine.
Tyler, I do hear an echo.
Yeah. Okay, so if that gets really obnoxious, let me know. Actually, you know what? I'm just gonna turn. Okay. All right.
No, that's great.
No, that happened to me. I had to click the watch stream, and then it singled out to just one voice.
Okay. Well, I have my audio speakers. I wasn't able to get my headset working, so if it becomes an issue where it's like unbearable, let me know. We'll do something different. Does it seem okay at the moment?
Maybe I'll just watch your screen and see if that works.
Okay.
Yeah, I was not getting an echo until I started watching Haxel's screen, so I need to shut down that extraneous.
Yeah. If I can get Haxel to just kill his stream, I don't know.
I'm actually trying to. I'm trying.
Oh, okay.
There should be a button on the
left-hand side.
Yeah, it says on live, and then you're streaming.
It's like just above where it says voice connected. It says cadCAD study group, and then to the right. Yeah. Boom.
There we go. Thank you.
Cool.
Sorry.
All right.
All good.
All good. How does the audio sound now? Is it still obnoxious?
Great. Nope, it's good.
Good for me.
All right.
Good.
All right. Can you guys see my screen? Should have GitHub up.
Yep.
Is that right? All right. So for those of you asking, this is the GitHub reference implementation repo. We have actual usable code in here. Although I gotta stress that this is sort of a moving target at the moment because this API that we're developing is being pieced together day by day and is subject to change. Now we have a lot of our primitives already in place, but even the stuff that we had a week ago, we're making some somewhat substantial changes to it. We're actually simplifying it, but it does change the API a little bit. For those who want to play with this, the best thing to do at the moment is to just go ahead and clone the repo, and then you can import these files here in the cadCAD subdirectory. You can actually import these files. They've got some classes defined in them. I guess not error, but spaces here. You can just import these classes and start experimenting with the new cadCAD engine directly. And I'll demonstrate. I have a project where I'm doing that very thing here. But this is available today if people want to start experimenting with some of the concepts that I'm going to talk about here in a minute. So I don't have a presentation or anything like that, so I'm just going to kind of tab through some stuff that I have pulled up. But I think that this is probably something that I think everyone should at least glance at. There's some math in here that I think might be inaccessible for some people, depending on your level of mathematics. But this is a fairly succinct document created by Zargam and Emmanuel Lima that describes cadCAD as a specification, as a language, as a framework, whatever you want to call it, a set of core concepts that I feel like is pretty well written and fairly comprehensive. This is essentially what we're going to be going over today, as far as the concepts go as they're implemented currently in cadCAD 1.0, and sort of how we're applying them, I guess, right? So this document here is in the docs subdirectory of the cadCAD RI, or the reference implementation repo. So you guys can check that out. I'm sorry?
I think that was just a mumble.
Okay. So I think that this document will probably need a refresher, just based on how much has sort of been solidified in our own mind, but the concepts are solid. These are not concepts that we came up with ourselves. Z didn't come up with them himself, but these are concepts that exist in dynamical systems and control theory, and have a strong sort of foundation in math. Which is why you actually see that here. Now, Z's background is in mathematics, and so when he writes these documents, you tend to get the math perspective more than everything else. Part of my job working on this cadCAD reference implementation is sort of doing this translation between what I call Z language, which is the high, the mathematics side of things, and translating it into something that I think somebody with very little to no math experience, and little to no programming experience might be able to do something with, right? So this brings me to my next point, which is, as you guys start exploring cadCAD through the study group, if you guys notice that there is a concept that is not being explained well, or doesn't seem to have a lot of resources available at the moment that adequately explain it, please let me know, because one of my top priorities is documentation. I really want this to be as accessible to everyone, the layman included, from all different types of backgrounds and experience levels. And I want that to be available from day one. The moment that 1.0 is pushed out the door, I want it to come with all this really good documentation. So on that point, if you notice something like that you want more information on, let me know, because that points me in the direction of maybe our documentation could use some work in that area. Okay, so here's what I'm using for the official documentation for cadCAD. Heater did talk about there is going to be a cadCAD wiki, which I think is going to be more community driven. It's going to be a place where we can link a lot of the community resources, experimental and demonstration models, tips and tricks, that sort of thing will go in the community wiki as like additional resources that people should check out, on top of cadCAD. But for cadCAD specifically, we wanted to have something that was locked down a little bit more so that you could sort of rest assured that if you see it in this documentation, it's at least meeting some level of accuracy. And everyone can pull this up if you want. It's available today, but keep in mind, just like the GitHub repo, this too is a work in progress. There's not a ton here because the API hasn't been nailed down yet. It's kind of a slow process here. But this is what I'm going to be using to drive the conversation today. And if at any point somebody on the call has a question about something that I say or something that they read on the screen, go ahead and jump in, raise your hand. No need to wait till the end. Go ahead and interject, and we'll answer your question right there while we're on that same thought. And then after we get done with this, I'll hop over and I'll actually show some code. I don't want you guys to take this as like this is what cadCAD's going to look like. This is what it currently looks like. But like I said, this API is a moving target. Some things have been set in stone, others haven't. But I want to show code because at least for myself, seeing cadCAD or a model, a very simplistic model in this case, implemented in code actually helps me sort of solidify some of these concepts that we're going to be talking about. Otherwise, it's just too abstract, and I can't really do anything with it until it becomes more concrete in terms of code. Any questions before I jump into the bulk of this or the meat of this? No? All right, cool. All right, so I guess the very first thing for those who know, great, but there's probably a couple people, in fact, I know there are a couple people here who have heard about cadCAD, who know that it's sort of a modeling framework, but outside of like those generalities don't really understand what cadCAD is or why it exists. And so let me just kind of briefly go over that. cadCAD is a framework, but sometimes we refer to it as a language, and I think that largely comes from that specification that Zargaman and Lima had put together, where they talk about these concepts in a way that sort of give you the language to speak about how these systems actually fit together and how they operate internally, right? So cadCAD is a Python implementation, at least in the reference implementation, it will be written in Python. But I like to think of it as a framework that gives you the cadCAD's formal language as building blocks so that you can construct models of systems, namely complex and dynamical systems. A dynamical system, if you pull the definition from Wiki, it essentially says that a system, or a dynamical system, is a system in which a point that exists in some space and its time dependency can be described through a function. And I'll talk more about that in a second, about what that actually means in practice. But I think the most simple way of describing the purpose of cadCAD is as the set of building blocks for constructing arbitrarily complex systems, whether they're very, very simple in nature or the most complex sort of systems that exist out there. And it's done in such a way that it's not imposing very much restrictions on you. There's there's language that you have to use to describe the system, but defining the behaviors and actually representing these complex relationships as they exist in these systems is all doable. We try not to impose anything except what we absolutely have to get some assurances about the execution of the models themselves, right? So I'm going to go ahead and start. I'm going to jump into the 4 things that I really want to make crystal clear to everyone on this call. And then next week, what I'm planning on doing is spending a little bit more time going over a step in the modeling process that I think a lot of people get tripped up on. I know myself, personally, I get tripped up on this. And that is taking a system from the real world that I'm interested in modeling and actually translating that into the language of cadCAD or generalized dynamical. It's like actually taking that and breaking it down into its smaller components to where everything is understood as far as the actors and the participants and the mechanisms and the relationships between all of that, right? So the 4 concepts that we're going to go over today: dimensions, spaces, blocks, and points. All of these things, like I said, we did not invent these. These are not things unique to cadCAD. These are things that come from the mathematics world of dynamical systems. So we try and keep the language and the vernacular the same, so that math people can do this. But hopefully, at the end of this, these concepts don't just make sense to math people, but make sense to everyone else on the call as well. Okay, so the very first building block of this new cadCAD architecture is called the dimension. And a dimension in its most, simple form is really just a data type. I guess you could think of it as also an attribute or like a name or a label maybe that goes along with that. But in its most basic form, a dimension really is just a data type. It's some sort of arbitrary restriction on a type of information saying that it must conform to this type, right? Some data types that you can use for dimensions are already built into the language. Obviously, you get primitives like int, string, int64. These are dependent on the language in which you're dealing, obviously. But a dimension can be any type of type, even a composite or like an arbitrary struct or an object or a class or something like that. And so as really what I'm trying to convey here is that the dimension is just the first lowest level restrictions that you place on some piece of data. For example, if you say, I'm interested in working with an age, it probably doesn't make sense to make that a string, but you would want to impose the restriction of saying an age should probably be an integer. And we'll see why that's important later. But let's go ahead and move on to the second one, which is spaces. And spaces are collections of dimensions. And the purpose of a space is to, I guess, restrict or I don't like using the word restrict because it makes it seem like you're limiting things, but really what you're doing is it's your way of defining sort of a schema for the information that's going to be flowing in and out of your system. And with spaces, you're able to say this is the shape or the form that I want my information to be in at a specific place in time, right? Now, we use spaces in blocks. This is where you're actually going to see them implemented and utilized. And so it'll make a little bit more to get down to blocks exactly how this gets used. But you can kind of think of a space as if any of you are familiar with that child's toy where you've got this like plastic box where you can put these blocks of different shapes through holes that are also shaped with the corresponding blocks, right? So there's like a star, circle, a square, whatever. Spaces are very much like that. That's how I like to think of them. It's sort of your schema that says I'm going to have a bunch of information, and that information needs to adhere to these restrictions. Now remember, spaces are pretty much just collections of dimensions. And your dimensions are what enforce or restrict on data type, if that makes sense. Okay. Now there is a point here. I'll actually come back to it, but spaces and points are not the same thing, but they are very interrelated. I'm going to come back to it, but just understand that a point is an instance of information as it satisfies a space, a particular space. I'll explain that more a little bit later. Okay, so blocks are sort of where I like to say where the fun happens in a system. A block, in a very simplistic form of the block, you could say that they are composed of three things. First, you have your input space, you have an output space, and then there's a function defined on the block that does some sort of transformation on the information in through the input space and transforms it to conform to the shape or restrictions of the output space. Okay. Now in the blocks, in the math world, actually, we call these input spaces our domain, and the output spaces we call a codomain. And like I said, the spaces themselves are just the schema. It's not the information itself, but it is sort of the rules about what the information needs to look like when it comes into the block. And then there's the codomain that describes what the information needs to look like as it leaves. The function or the block function is what performs the process or the transformation of that information from one to the other. Hopefully that makes sense. Okay. The last...
Can I ask a question just to make sure I understand that? So then my input could be 2 dates into the block. The block is a transformation to calculate the difference between the dates, and then the output is the, say, number of days between the 2 dates.
Yes. Yeah, and I actually have a very example here in a second that I'm going to kind of work you through. It's funny that you would say age. Maybe you saw the JSON below, but yeah, this is exactly, well, not exactly, but very similar to the example that I have here. But that's exactly right. Your input space or your domain defines the type of information that's coming in. In your example, it would be a collection of ages, right? Or I guess 2 of them. And then your output would be also an integer, I suppose. but it would be the difference between the two. How many days between those two dates, right? Is that what you were saying, Chris?
Yeah, and I didn't see below. It just came to my head. So.
Oh, yeah. Okay. So I've used age a lot. For me, it's just like something that everyone is familiar with. We all have, right? So this is something that I use in my own, like trying to understand the concepts as I'm exploring them. And it is very contrived. It's not very useful of an example, but hopefully this example right here will better describe how these things fit together. So points. Points, like I said before, points are instances of information that satisfy a space. Okay. You can think of points as the object of information, or whatever you want to call it, that is flowing into a block and coming out the other side. However, it is worth noting that at least in the context of cadCAD, the point that gets put into a block is not the same point as it comes out. A whole new point will be generated. The point that comes in has to conform or has to satisfy the restrictions of the domain, and the point that gets generated and returned from the block needs to satisfy the space that was defined as your codomain on the block. So let's kind of look at this. So I have an example here. 3 different people, and I have a system, if you will. It's a very simple system. There's no looping mechanism. There's no external data that needs to be fed into it. Nothing like that. This is as primitive as you can get. But I have a system here that's composed of just a single block, and its input information is 3 different ages, 1 age for 3 different people: Alice, Bob, Charlie. And you can see here that I created my first space. This is my domain space, right? That says I've got 3 different keys here. I've got Alice's age, Bob's, and Charlie's, and they're all ins. Now, this right here, just by itself as a unit, you can think of as your dimension. And the space as a whole, I'm representing it in JSON, but it won't be in JSON in the reference implementation. It'll be Python objects. But I just want you guys to sort of visualize this, and JSON objects are pretty simple. So right here, you can think of this as a dimension, and this is a dimension, and this is a dimension. Now there's 3 of them, and they're all of the same data type, but they're 3 independent dimensions. They've each got their own corresponding labels so that they can be sort of checked, I guess, or mapped correctly later on when a point is actually introduced. And then we create the codomain, which is a different dimension. It's a float and a different label for it, a different key for it. And then right here, I have an example of what maybe a block function would look like that actually did the translation between our domain and our codomain, or the incoming point to the outgoing. So here you can say I have a function defined as calculate average. It takes in our point. This is very verbose, obviously, but I want this to be crystal clear. We take, all this function does is take the 3 ages, adds them together, divides by 3, and then returns a new point, right? Where the average is the only dimension, right? This point right here conforms to that, and this point that was passed into the function conforms to this. It satisfies that space that was defined. Now, cadCAD will do the actual checking and the type safety and that sort of thing to ensure that you're not passing a point in that does not completely satisfy the constraints of the domain or the codomain, right? You have to obey the rules that you set up earlier, or you can't pass information to that block. It won't execute. Okay. Now, in order for our block to do something, we have to create a starting point. In this, I just want to kind of emphasize that this is the difference between an actual point and instantiation of information, which is similar but different than the actual space. The space is the schema, and the point is the actual instance of data that conforms to that schema, if that makes sense. So right here, I've created another JSON object. I've given it 3 keys here that correspond to the space up above. I've given them some integer values. And then if we execute our block and pass this in, we get this object, or I'm sorry, this point back, which is, of course, conforming to the codomain space. So that is like the core of it. And I know I kind of glossed over everything really fast and moved through this really fast, but I want to open it up for questions, because as simple as this seems to me, I've been doing it now for a couple months, really kind of, working with these concepts, and I tend to oversimplify it now. So if there's anything that I've talked about right now that didn't make sense, let's make sure it does for everyone on the call, because next week what I want to do is start taking people through the process of identifying a real world system that you're interested in modeling and fitting it into these building blocks. And you can't do that if you don't understand what these building blocks are or how they interrelate with each other. So.
Question.
Go ahead.
Okay.
You go ahead.
It's really hard to actually read. So I was trying to link to the cadCAD read the docs.io, but that's sort of blocked. Is it open or?
Yeah, it should be. I can drop it in.
I posted it already in the cadCAD study group.
Okay. Yeah.
Okay, cool.
It's open.
Yeah, it should be open. Like I said, though, you feel free to look through there, but outside of the crash course, which has been updated today, there's stuff in this Read the Docs project or whatever it's called that might be a little bit out of date. But if you keep checking it, we try to keep stuff that we think is going to stick around long term there, so it shouldn't be super off. But some of it might not be accurate, a month from now.
Perfect.
I will be updating the docs as we go too, so something you read today might be different tomorrow.
Thank you.
Mm-hmm.
I have a question.
Sure.
I don't know if it's gonna be well thought. If I make a mistake, please tell me. But I'm trying to figure how this thing that you just showed us, by getting some inputs, right? I need to have the inputs from the system, and then this program, what it's going to do is kind of predict the tendency of those inputs, something like that. I don't know if that is well explained.
Yeah, I guess
But
yeah. I'm sorry,
sorry.
go ahead.
It would seem to me. Sorry, let me just finish it. Maybe, and then you tell me if I'm wrong or not. It seems to me like the thought of this is that given enough data points, or that if we knew all of the data, from a given system, then we would be able to determine the outcome of that system. So, in short, predict the future. Now, I don't know if I'm mixing concepts here, but for example, wasn't it supposed that when you do that, the complexity goes very high and you get chaos? I don't know if I'm mixing a lot of things. I'm not really a mathematician, but it's what I think when I see this.
So you're not far off, and I think that you're getting at sort of the meat of what cadCAD is and where its usefulness is going to be. So in my contrived example, obviously we had to start with some data that wasn't really interesting. And yeah, it produced the average, but why would anyone build this model when you could just do the math yourself in your head? There's no reason for this. But where the complexity starts to be more interesting, I guess, is when you start composing chains of blocks together. We actually have something in cadCAD as well called a dynamic. Again, not new to us, but there's this concept of a dynamic that says you can actually take a system of blocks that interact with each other. You can actually feed them in as into another system as if that entire system itself was just a single block. So there's this sort of snowflake abstract I don't know what you would call it, composability, where you're able to sort of zoom in and out of various levels of complexity as you design these systems. You can think of a system as potentially being composed of a bunch of subsystems. And in fact, that's what complex systems are. There's that nested hierarchy there. And you can describe that in cadCAD using the concepts that I've just gone over. But to get back to something that I think might not be crystal clear is this process of creating that initial point, right? I guess for me, one of the things that I didn't understand immediately was, well, why did you need that? Isn't the point of the system to just generate data? And yeah, it is, I guess, but more specifically, you're taking a signal of some sort and you're doing something to it, and in an attempt to produce some sort of desirable outcome, right? Output signal. But to kickstart the simulation, to kickstart an experiment, you would need to have that signal defined as your starting parameters, right? Your beginning space. And then essentially what you do is you feed it into that first block, and then that block will produce a new point, which gets fed into another block, or maybe a couple different blocks, because we do have the ability to sort of create these topologies where there's forking and looping and that sort of thing. But the end result is that with each iteration in time, you're producing a new point of data. And then you sort of aggregate all of those points of data together at the end and start, investigating and studying the data, analyzing the data to make sense of what actually occurred in the system. Does that make sense? I don't know if that exactly answered your question, but
Yeah, I mean, I of course have to understand this a little bit better and like research a little bit more on it. But yes,
I mean,
so
but
I was not that far off.
no, I don't think so. I think your intuition is correct. You feed some information out, and then and these systems can be as complex or as simple as you want them to be. At Block.Science, I work with a lot of really seasoned modelers. And let me tell you, they've built some models that are just very, very, very complex. There's a lot of knobs and levers, and sometimes that's what you need to do in order to get a useful model out of it. But they don't always have to be that way. I think a lot of the more simplistic models can still be useful in telling you something. But yeah.
Okay, thanks.
Mm-hmm.
Can you please explain the spaces? I mean, I got the point about blocks, but I had a hard time understanding spaces.
Sure. So the space itself, to kind of go back to the analogy I was using before, a block, basically, I like to think of it as like a conveyor belt. You could think of it as a conveyor belt even, like the pizza oven, where on one side you've got the pizza that goes in, some sort of transformation happens, and then you've got a cooked pizza on the other side. The oven itself would be the block, and the input side of the block or of the oven would be your input space, and the output side would be your output space, or your domain and codomain. Now with the pizza oven, it's not a perfect analogy because it's just a big open hole that the pizza goes through. But you could imagine, there's a TV show, I can't think of what it's called right now, but it's a Japanese game show where they have this conveyor belt going that the contestants stand on, and then there's these shapes cut out of the wall. And the conveyor belt is moving the players towards the wall, and they have to position their body in such a way to fit through that hole. And obviously it's very hard for them to do. But you can think of a space as essentially that. It's a set of rules about what the data coming into the block has to look like, right? And then also the definition of what or the schema of what the information needs to look like as it leaves the block. And the reason why you have to make these sorts of restrictions ahead of time and make them well defined ahead of time I think that people like Z could probably give you better definitions or reasoning behind that because it has to do with the math. But from a software engineering perspective as well, it allows you some sense of safety, right? You know that points that get fed into a block are always going to have the information that you need in order to perform the transformation on the data, and that it's always going to produce a specific type of data in the end. And if the data ever being fed to it does not conform, it just doesn't run. And also, if you define a block function that doesn't spit out the correct type of data, or if a process causes corruption of that point, and so it no longer satisfies the codomain space, then the block won't produce anything, and we can raise exceptions in this case, let you know that's wrong.
I have a quick question. So on the codomains, is that within the library, so that it knows that those codomains are the possible universe that can comply with the with the domain, or is that sort of free flowing and there has to be a logic applied?
So sort of both. We give you the building blocks to define the spaces yourself, and then you define the spaces ahead of time. Then you attach your spaces to your blocks, and then at any point when you wish to throw a point through a block, the block itself internally is responsible for saying, okay, you're trying to call me or execute me with this point. Does this point or this set of information, does this object of information, does that conform or satisfy the restrictions of the domain space? If it does, go ahead and try and run it. Then the block function will produce a new point, and then again the block does a check that says, okay, we just generated a new point, but does it satisfy the requirements of the codomain? Let me just really quick show you some code. Now, like I said, this API is very likely to change, but I think that this will probably solidify some of these concepts for many of you. So here I'm importing all 4 of those primitives that we've talked about: block, space, dimension, point. I've also included a couple things here just to help me out so that I don't have to do things quite so, I guess, verbose. But I create some custom data types here for a rock, paper, scissors system. Now this example or this model is very similar to the one that I used in the documentation here in the crash course, where I take some information and I spit some information out, but that's the extent of the system as a whole. I don't have any looping mechanism. It's not a closed loop system. There's no external data being fed into it. It really is just the sort of single block system. Okay. So here I define 2 different data types, which I am going to use in my dimensions. I create a dimension called choice, and here this is just a name for it, so we have a human readable label. I create another dimension called outcome. Outcome, for if it's not immediately clear, just tells you who won or if it was a draw. Now I create my spaces because I've defined my dimensions. Now I can create my first space. I'm calling it my game space. This is effectively the domain for my block. I pass in a list of dimensions that will make up this space. Now I'm using the same one twice here because this data type is the exact same, but I want there to be 2 of them. So I pass in choice as my first data type, my second one. I give my space a name, and then here is a convention for providing override names, because if you don't provide a name here, this will be referenced by this name that we gave here. But since we have 2 of them, they can't both be called choice. So what I've done is just provided some override names. Now, like I said, this API might change. Don't get too fixated on it. But what I've done here is created a space with 2 choices, one of them for player 1, one for player 2. Now, they are both labeled this, but their type is type choice, which is this enumerable type right here that I created. Okay. Now I create my codomain space. This one has just a single dimension, outcome, which again is an enumerable type right here. I give it a name, outcome space. And then right here, we're going to skip ahead just for a second. I actually define my block. This is the game. This is the system. It is a single block with its domain being the game space and its codomain being the outcome space. Now, the first parameter here is my actual function, which will be called when you run the block, right? It's what takes the game space point and produces an outcome space point, or your domain point into a codomain point. So if we come up here to where I've actually defined the function, I've got a little trick here. You don't have to understand what this is doing, but this essentially takes the two choices made from our point, okay? Player 1's choice, player 2's choice, and it decides who the winner is. Is it a draw, or did one of the two players win? And then it returns a new point, which right here is the data for it. Okay, we have an outcome key, which satisfies this right here. This because of our outcome space only has one dimension, and it's inferred that its name would be outcome. So we call it outcome right here, and it has to be of type outcome. So then we pass in our winner as the outcome data type. And then right here, when you instantiate a point or create a point, you actually specify the space that this data has to conform to or has to satisfy. So in this particular case, I put my codomain, and this point will not even be created. It won't be instantiated if the data that I supplied here in this dictionary doesn't actually conform to this. So just by way of having the point instantiated lets me know that the data that was provided actually satisfies this space. Okay. Now, when I want to run the block, there's a map method here, which takes a point and produces a new point. Now here, I didn't want to randomly, or I didn't want to manually create a game point beforehand. I wanted it to be randomized. I wanted to be able to generate them randomly. So you can see here, this adheres to game space, which is our domain, and it's got two keys, player 1 choice, player 2 choice, but notice that these P1 and P2 values have to be of this type, because that's how the space with its dimensions was defined. And then what I do here is I'm actually just randomly choosing some options. If I run this, hang on, I might need to run this. Okay. You can see here that a new point was created. It's an outcome point or a codomain point, and its value is that it was a draw, right? So it applied get choices to randomly generate an input point. The map function ran, this determine outcome function ran, and it produced a winner. Well, in this case, it was a draw, but yeah, an outcome, I should say. Now here I've got the ability to just generate a whole bunch of games, 100 of them here. Let me just run this real quick so you can see. Here we've got 100 different outcomes of various states. But hopefully this sort of solidifies how these things work together. It's really just your dimensions, you define your spaces, or I'm sorry, your types, your dimensions, your spaces, your block function, then you put it all together. And then when you run one of the blocks, you get a new point, which could then be fed into another block. In this particular case, we just have the one block. In the coming weeks, I'll show you how we're thinking that you will string these blocks together and create more complex systems.
Tyler, can you explain to me, or repeat maybe, what's the new great thing about 1.0 versus the previous version on this topic?
Sure. So I'm not the best person to answer this because I was never, and still am not, a modeler. In fact, the reason why I picked up this cadCAD reference implementation as something that I wanted to work on, I mean, there's numerous reasons why, but one of the big ones was because I wanted to become a better modeler, and I wasn't very good at using cadCAD Legacy. But some of the stuff that I can tell you from my own personal experience is that the API, while perhaps more verbose here than what you might expect, is much more simple than what was required for Legacy. There's less boilerplate. There's less. I guess what you could say is we are doing a better job of taking the complexities of the engine and the flexibility that the engine provides and hiding it away behind defaults so that when you create dimensions, spaces, blocks, and put all of this stuff together, the 95, 99%, whatever it is, 99% of the time, you're not going to specify configurations or parameters, because for most people, for most models, you just don't need that. It's for those sort of outlier edge cases where you need to be able to override. So our API has become much more simplistic because we're trying to hide a lot of the complexity behind defaults. So that's another big reason.
Can you also explain to me what you mean by the API? Because, I mean, working on the past versions, I thought I downloaded a version that I could actually manipulate pretty extensively. And the concept of the API was sort of like, okay, I need to find data. So how does the API lingo fit here? Does it mean we're not going to download a model in version 1.0? We're just going to use a model sitting somewhere on a cloud somewhere?
No. You write your own model, but you are responsible for seeding it with that initial point. So there's no downloading of anything. Although, just as a side point, I do want to make this clear that we do hope to have a bunch of models that are just generally useful for a number of like basic things that are available so that you can download them, modify them to fit your particular system, and you don't have to.
I create a model on a cloud, not on my own laptop. Not correct.
No, you can run this locally.
Okay.
Yeah, there's nothing on the cloud. You'll import cadCAD just like this. The only difference is that this Jupyter notebook that I have here is importing cadCAD directly from the cloned project. In the future, what you would do is you would say, from cadCAD RI import, right? Caps lock, no. Block, space, whatever, right? But this package would have to be pip installed, and you can run it locally. You don't have to do it in the cloud. In fact, when you say in the cloud, I'm not exactly sure what that means, because you could run it on Google Colab, for example, or shameless plug, you could run it on Labs, which is built exactly for running cadCAD in the cloud, so you don't have to mess with your local environment.
Okay.
But that's a different project entirely.
I think there's some confusion over the term API, as it's often used to describe like a web interface for data.
Oh, I got you. Yeah. I got you. Yeah, I'm dumb. Yeah. Not talking about API like a RESTful API or an RPC API. When I say API, what I'm referring to is the language of cadCAD itself. For example, this right here instantiates a new dimension. The API is the class as it's defined here, that says what parameters need to be specified and how you sort of interact with these objects. For example, I create a block here, right, called game, and you can see that there's a method here called map. That map method is something that we chose to create and make part of the block class. Those sorts of decisions about how to interact with cadCAD is what I'm referring to usually when I talk about API decisions. It's, how do we make cadCAD easy and more able to be reasoned about, and to make it more fun. I feel like there was a lot of heavy lifting And one thing that I heard a lot from people who were developing with Legacy was that there was a lot of stuff that they were doing, but they didn't know why they were doing it. And I'm hoping that with the 1.0 rewrite, that because of the primitives that we have here and the way that we're asking you to put them together, that a lot of these concepts are going to be more clear. It might not be clear the very first time you do it, but if you do it a couple times, you're going to start to see, just through experimentation and experience, you're going to start to see the relationships between all of these and more easily be able to reason about why we do things the way that we do.
Yeah. Also, too, the community call where we did the major announcement about, hey, 1.0 is coming, these are the motivations behind it, that recording should be available. I'll also make the slides available too. So if you were not able to attend that community call, we can make that available. We could just link the video for this group here. And it covers in depth more the design philosophy and motivations behind the new version of cadCAD we're developing.
Can I ask a question on the same note, actually? Will this session be recorded and distributed?
Yeah, it is being recorded, and we will make sure that we drop a link to the video in the text channel.
Amazing. Cool. Awesome. Yeah. Just another question from my side. I'm not a maths. I've not done anything with maths, like in terms of like education wise, sure. And I haven't touched programming in a very long time. What do I need to do to get up to speed?
Yeah, so okay, that's a great question, and I'm right there with you. So I'm a high school dropout. I never even finished algebra. So being thrown into the mix with people like Z, who come from that PhD mathematics level, and then seeing all the literature that he hands me that's here, this is what you need to build, it's very, very, very overwhelming. And one of my main concerns in tackling cadCAD in this reference implementation is trying to bring that language down to a level where you don't have to have math and you don't have to have the programming. So if I'm doing my job well, you won't have to have much of anything. Now, I will nuance that or caveat that with one extra thing, which is that the reference implementation is going to be written in Python. So if you wanted to learn anything, I would say just get Python installed or install Jupyter or play in Google Colab or Block.Science Labs even, and you can start experimenting with Python. But I don't think you're going to have to be an expert in Python to start doing meaningful things in cadCAD. And you certainly don't have to understand sort of the theoretical math that went into designing and architecting cadCAD.
I
have a question.
One last question. So if I was to sort of go and, I don't know, do 4 or 5 hours a week of Python between now and the beginning of the, whenever the token engineering course kicks off, would that would probably be a good position to sort of learn from?
Oh yeah, definitely. Even just one session of 4 hours, I think you're going to pick up the basics of Python. Python is a beautiful language for first timers. And as long as you kind of understand variables, how to interact with classes and functions, you basically got everything you need to start at least experimenting with cadCAD.
Okay, nice. Thank you very much. Appreciate that.
Yep.
Hello, sorry. When you mentioned spaces, right?
Yeah.
So could I put like a low pass filter as my space or something slightly more complicated, like the output of an FFT or something like that?
The short answer is you can put anything as a space. All the space is a collection of keys and corresponding data types. That's really at their core. That's all it is. So you're saying.
Okay, so so let me rephrase that. So let's say I'm using SciPy, the library, and I've written a low pass filter or a band pass filter, and I expose that as a class. Can I use that as a custom space?
Yep.
Okay.
And that's something that we're going to talk about in future calls too. So I'm no Python expert, and I definitely don't know a lot of these like SciPy, NumPy. I don't know a lot about them. I don't use them personally. But one thing that I've had to sort of address, or we all have, not just me, but we've had to address in our design of this new reference implementation was, what do we do when we take these sort of base classes that some of these third-party libraries that are in wide use, when people want to use those? Let me give you an example. In NumPy, there's a type that the library gives you called ND array, which is your multi-dimensional array, right? The problem with using that in cadCAD is that ND arrays don't come in one size fits all. Like there are different flavors of ND arrays, namely what your data type is underneath, and also the size or the shape of the ND array. So what I do is when I want to create a dimension, so let's say I have something like my ND array, I could do something like my ND array 2 by 2 integer, right? And and that would be, oh, I'm sorry, this would be dimension, right? And that's my actual type. And then I could instantiate my ND array I wouldn't do it here. I would just give this a name, ND array. But when it came time to like instantiate a point that conformed to this, I would have to use this subclass in order to instantiate data that conformed to it. But in order to get this type, I had to subclass it. So I don't know if you're class my ND array, sorry, integer, and then this would be like numpy ND array. And then here is where you would actually, init function or whatever, you would instantiate basically a 2 by 2 by 2 ND array of type integer and then return it. And then once you've subclassed, you have the ability to use this as your dimensions class. And there's a lot of places where you would have to do that. But yeah, you can do that.
Yeah, thank you.
Hey. Another stupid question. Can this be ran in a Conda environment?
Yeah, absolutely. Yep. Anywhere you can run Python, you can do this. It is just a normal Python library or framework. And so yeah, you can run it in Jupyter notebooks, you can run it in Conda, wherever you want. And one other thing too, I'll say about the reference implementation is that we're trying very, very hard not to include any dependencies, so that you don't run into weird issues, with your dependency tree conflicting with your models or whatever. We would like you to just be able to install cadCAD, 100% pure Python, no external dependencies, and leave that up to your model to include those. And then one facet of that that's probably worth noting is that the reference implementation, because of that, and because it's supposed to be used as a reference for other developers, we're not making it super performant. It's not going to be efficient in a lot of ways, especially the more complex your models get. It will run everything, but it will not run it as fast as some other alternative cadCAD compatible implementations will. So the idea is that using that formal spec, let me just switch over to this again. The idea is that by creating this formal specification and the reference implementation, we basically have documented how we suggest people create their own cadCADs. And in the future, there will be other implementations that address things like, performance, if that makes sense.
Yeah, there's already projects in the works that are intended for more sort of like production large data science data sets. We're building one in the Julia framework right now. What the reference implementation we're showing here is intended for complete ease of use. It's not to say that it won't have it won't be performant. It's just that that's not what we're optimizing for. We're optimizing for the experience of getting in and expressing your models. And because they will be written in Python, the idea is that you could bring those models over with minimal refactoring, if any at all, into the Julia framework if you need to run it in the most performant way possible.
Yep. I want the code for 1.0 to be documentation. So there's going to be a lot of stuff that we do internally that I'm sure the seasoned Python programmers out there are going to be like, what the hell? This is not how you should do this. And you just try and keep in mind, this is a representation. It's meant to document the internal function of cadCAD as an engine so that the other implementations have something to sort of work from, if that makes sense. But yeah, this is your educational cadCAD. That's everyone's first introduction to cadCAD will probably be the reference implementation because its accessibility is like top priority.
Hey guys, I'd like to ask a question, and also maybe it's kind of like a lead for your team to investigate. I'm curious about sort of ecosystem compatibility across Python. So I know like there's a few concepts here that I've seen in other places. So the concept of named dimensions as containers is really a core philosophy behind Xarray and the HoloViews library. So I'm wondering if your development team has come across that, or it might be an interesting lead to investigate to see how they've done it and what they build from that.
Yeah, absolutely. So I'll put it down on the list of to explore. So we're like definitely open to this external input. We're not trying to develop this in a cave by ourselves. We want it to be useful for everyone. And actually, I should probably mention that dimensions themselves are changing. In the future, you won't, like in probably the next week, you won't have to define dimensions like this ahead of time. It'll be done sort of implicitly at the time that you create your spaces. We just felt like this wrapper, this sort of taking a data type and giving it a label, instantiating that as a new object was one layer more that we didn't really need. You don't really do anything with it except append it to a space. I'm sorry, down here. And so we probably didn't need to force, explicit dimension creation like this. We could just sort of infer what needs to be done at the time that you instantiate a space. So dimensions in particular are, at least the class, are going away. But I'm going to put that on my note to look at. We've been talking to people like, what's his name? Travis, the author.
Oliphant.
Yeah. We've been talking to him. He's got some ideas about how to make this a better user experience, especially once you start dealing with types. Things get hairy really quickly, and we want to be flexible, but we want to make some assurances about the data flowing through a system, so that it behaves in ways. And obviously, he's the type of person you want sort of advising and giving on that for sure. So
yeah, he's the guy for those two that I mentioned, and there's even in NumPy, directly in NumPy, and I think he works on a library called Numba. The concept of named dimensions are really important to all these. So he's going to have really good advice. But the two that I mentioned there, HoloViews and Xarray, use this concept very explicitly. And I'm not sure if they use the same underlying infrastructure or if they have their own implementations. But Travis is going to have so much knowledge on that. But the other thing I wanted to mention is from reinforcement learning, and specifically the stable baselines library by OpenAI. And their fundamental data structures for that are sort of like action spaces and observation spaces. So and that looks kind of similar to how spaces are defined here. So that might also be an interesting lead to look into.
Yeah, it wouldn't surprise me if there was some very, very, very close parallels between the two. In fact, Z links me to the OpenAI stuff all the time. So I suspect that there's a lot of shared concepts here. And like I said, nothing that we've put into cadCAD is new. We're not inventing anything new. We're borrowing from, these fields that have existed for a very long time. Control theory and systems engineering. These are concepts that have been around, well established. We're just putting them together in code and hopefully giving you that API, that access to these concepts in a way that doesn't feel overwhelming, but still allows for the flexibility that you need to be sufficiently expressive.
Also, one last thing. Every 2 weeks, we have a public-facing core tech engineering working group over in the cadCAD Discord. So Sean would love to see you there. This sort of feedback is really helpful for us to sort of make sure that the left and the right sides of the brain are in sync with each other.
Awesome. Thanks, Chris. So on that note, I have 2 questions. One is, where can I find the link to that specification paper, Tyler, that you had on the screen? And also just the sort of calendar for what you mentioned, Chris.
Yeah, I can also jump in. So the links to the things that we've mentioned today, I've been keeping kind of notes on my side in the one-stop shop. And so we'll post the links in the one-stop shop. I'll share the link in the one-stop shop to the one-stop shop in the Discord. And yeah, include the calendar as well. So
and which channel, Peter?
There's a cadCAD study group channel in the Token Engineering Discord. They're like a text channel. So we're in the voice one right now, but
in text counterpart.
Yeah, the text counterpart. And that's where conversation is. Oh, it's already happening. Cool. But yeah, so I also have to interrupt because we're about at the top of the hour. But I mean, this is just the plan is to basically continue this for the next week or so. We've obviously covered a wide range of like high level programming, math language, and also like talking about baking pizzas. So there's quite a range of ways to express this stuff and conversations to have. And I hope that you all at least learned something. Some of it was at your level, wherever that might be. And we'll just continue to build on this over the next few sessions and get more of a foundational knowledge about cadCAD, and then start to kind of craft what learning goals we might want to set for ourselves to work towards, whether it be documentation, if like you still are refreshing your Python, or if you want to jump right into the programming stuff, whatever it is. And yeah, so we'll continue this all next week in the same place. I will share all the links and information like slides and recording and stuff in the Discord, just so we're all on the same page. And I'll probably send a calendar invite again to the same group just for next week so that nobody is missing out on the location. So that's all I have. Any like last comment, Tyler, or anything?
No, that's it. I'll be available, in the study group channel. So if you guys have questions, go ahead and pepper them at me. I might not get to them right away, so I'm pretty busy, but I'll try to address it, a couple times a day. And also if you guys have suggestions for things that you would like to maybe explore more week to week, let's get that out into the open and talked about in the text channel, because I can sort of cater what I talk about based on where people are needing help and attention.
For sure.
That's it.
Cool. Awesome. Yeah, we'll keep iterating and working on structure and stuff. And if you had some difficulty with like connection or at any point during the hour, I had good Wi-Fi, so the recording will have the audio covered if you need to review some of it. So cool.
Excellent.
That's
thanks,
that.
everyone.
Yeah, thanks everyone for joining. Really appreciate it. Hope to see you next week.
Thank you very much.
See ya.